Okay, I am going to go over example 3 in the textbook, which is on page 822, and I want you to tell me where I make a mistake. So let's get started. Now, I know that the function s of n is equal to the summation from I equals 1 to n of the quantity 1 plus I over n quantity squared times 1 over n. And then I want to find the limit as n approaches infinity of s of n. Now we're going to get started. First, I am going to scroll this up a little bit, and then we're going to get to writing. First, I'm going to write down my limit, s of n, not the limit, I'm sorry, the summation, equals the sum from I equals 1 to n of 1 plus I over n quantity squared times 1 over n. Okay, now I can do a couple of different things here. But I'm going to start by finding a common denominator of that expression and adding them together. So I'm going to say s of n equals the sum I equals 1 to n. Notice I'm writing the summation every time, and I'm also going to write s of n equals every time because I don't want to forget what I'm doing here. And this expression here, well, 1 is the same as n over n, which gives me the same denominator as I over n, and that's squared all times 1 over n. Now, I'm going to move that up a little bit, and I am going to say s of n, no you don't. S of n equals the sum as I equals 1 to n of n plus I over n quantity squared times 1 over n. There. Now I can play around. First thing I see is I got a constant. But let's simplify first. I equals 1 over n. And then I'm going to say my n plus I over n quantity squared. The top is going to be n squared plus 2in plus I squared over n squared, but times n, so that's going to be n cubed. So what did I do there? Well, I squared this n right here. I squared that because of this exponent right here. And then I multiplied it by this n, and that gives me n cubed in the denominator. Now, I have a constant. Where's my constant? My constant is right over here, this 1 over n cubed. I'm going to bring that out. I challenge you to tell me which property of summations I just used. So s of n equals 1 over n cubed times the sum from I equals 1 to n of n squared plus 2in plus I squared. Now that I've done that, I can split this up a little bit, can't I? I got s of n equals 1 over n cubed times the sum from I equals 1 to n, 2n, forgive the technical difficulties, 2n of n squared plus the sum from I equals 1 to n of 2in plus the sum from I equals 1 to n of I squared. You're out practice a little early. Okay, now I can do more stuff to simplify. So let's do that. Let me move this up and let's simplify further. So s of n equals 1 over n cubed of, well, n squared. That is n times n plus 1 times 2n plus 1 over 6. That was property 5, I believe, plus, now I have a constant. For this middle term, I got a constant here and a constant here, so I'm going to bring that out front. And then I'm left with I. Now when my function is I, then I know that this is going to be n times n plus 1 over 2. Oh, snap. And then plus, I'm running out of room. Oh, I know what I can do. I can just bring it over and do that. Yay. I can do, now I got I squared, which is also n times n plus 1, n plus 1 times 2n plus 1 all over 6. And I finish my parenthesis. So now I can simplify. Let's bring that back over. Yeah, let's make that smaller so that I can do some work. We're going to be able to shrink this down a little bit in a minute, and then we'll be able to blow it back up again. So s of n equals 1 over n cubed times, when I multiply this, it's n times n plus 1 times 2n plus 1. So we're doing FOIL on that. That's 2n squared plus 3n plus 1 all over 6 plus, and then I'm going to multiply this through, 2n times n is 2n squared times n times and times 1. So I'm getting 2n cubed plus 2n squared all over 2. And then this one I get the same exact thing. I get plus n, plus, oh shoot, I didn't want that, I wanted that, plus n times n plus 1 times 2n plus 1 over 6. Okay, now I'm going to move that back, and I am going to multiply that n through on those two functions. So s of n equals 1 over 3 times 2n cubed plus 3n squared plus n over 6 plus 2n cubed plus 2n squared over 2 plus 2n cubed plus 3n squared plus n over 6. Now, How did I get that? Well, this thing right here is the same thing as this thing right here. And so I simply repeated the multiplication steps that I got to get this, and that's going to be the same thing. So now I am going to move up one more time. I'm going to move up one more time, and I am going to simplify this again. And I got S of n equals, 1 over n cubed. 1 over n cubed times what? Well, I got, these have common, this and this are common denominators, so I can add those. So I'm going to get that. I'm going to add 2n cubed plus 2n cubed, that's 4n cubed. 3n squared plus 3n squared is plus 6n squared. And then n plus n is plus 2n, that's all over 6, and then plus, and then while I'm at it here, I'm going to make this term right here have a denominator 6, which means I need to multiply the numerator and the denominator by 3. So I'm going to get 6n cubed plus 6n squared over 6. Now I can add those bad guys, and I'm going to get S of n equals 1 over n cubed times 4n cubed plus 6n cubed is 10n cubed. 6n squared plus 6n squared is plus 12n squared plus 2n all over 6. And now I'm going to multiply through, well, I'm going to scroll up first. I'm going to multiply through by the 1 over n cubed. So S of n equals 10n cubed plus 12n squared plus 2n over 6n cubed. Now, you might think I'm done, but I'm not, because remember, we wanted to find the limit as n approached infinity of S of n. And S of n is a rational function, and the order of the numerator, the polynomial in the numerator, has the same order as the numerator, or as the order in the denominator. So it's an order 3 polynomial divided by an order 3 polynomial, which means I can just divide the leading coefficients. The leading coefficient is 10 and 6, so this is 10 over 6, which equals 5, which equals 5/3. And that answer is wrong because I made a mistake earlier. Remember, your job is to find it. Happy hunting!